Okay, so let's do another example. So this is example 2. And we need to find the limit. And yeah, it looks like this. So limit with x approaching 0. Right? So that c number is 0 this time. And then the function is x over square root of x plus 1. And then minus 1. Okay, so at this point, we cannot plug in that 0 into the function. Right? So if we do, we get 0 on the top. And then here we have a square root of 0 plus 1. And then minus 1. Right? So we get, again, 0 over 0. So that's that indeterminate form. And we have to calculate the limit in some other way. Right? We have to maybe change this equation, right? Rewrite it in a different form so that I don't get 0 in the denominator. Yeah, so we'll do that in a moment, but let's start with actually graphing it. So we'll find that limit using 3 different approaches. So the first one will be graphical approach. And then we'll use the numerical approach. And then finally we'll just use an analytical approach, we'll solve it. Okay, so let's start with that graph. So 1 coordinate system. Yeah, so you can graph it somewhere if you want. Let's see, so this is -1, -2, 1, 2, 3. Okay, so the graph is very similar to the graph of square root function. There's a hole right there at +2, and then the graph starts at -1, 1, and then the shape resembles the square root function. Okay, so something like this. So this number right there is 2. 2. This is 1, -1. Okay, so when you look at the graph, right, when x's approach that number 0, right, so we see it, right, when we look at the limit, right? So let me maybe use the pointer. Okay, so yeah, so right here, right, it says x approaches 0. So x approaches 0 from 2 sides, right, from the right, right? X's are getting closer and closer to 0, and from the left. Right, so the closer the x's are to 0, the closer the y is to 2, right? The limit is getting closer to 2. Okay, so yeah, that's our conclusion, right? That's the limit. So limit with x is approaching 0. Then we have this function x on the top, square root of x plus 1, and then minus 1. Okay, so that limit is equal to 2. Okay, so that's our first solution, first first approach, right, to solve that limit. Okay, so the second was numerical approach. So let's make a table. So this is 2, number 2. So table, and with values with x is getting closer and closer to 0. Okay, so we have x, and this is y. All right, so we start with numbers to the left of 0, right? So let's start with negative 0.1. Right, so we basically take that negative 0.1 and plug it into the function. So if we do that, let me remove that. Okay, this, and that, and we make it farther away. Okay, so we plug in that negative 0.1, right, the number that's relatively close to 0, from the left, looking from the left, and we get 1.9999. I still don't have enough space. Maybe I should do it this way, and then 49. Okay. Then if we take a number even closer to 0, which is 0.001, and negative, we plug that number into the function, into that expression, and we get 1.9995. Okay, and then we could plug in the numbers that are to the right of 0, right? That would be, let's take that similar, the same number, but the opposite, so 0.001, right? This time it's a positive number, right? So yeah, we get 2.1, 2, 3 zeros, and 5. Okay, and then we can continue, right? We could I don't need that much, but we could plug in that 0.1, and then we'll see we get 2.0049. Okay, well, so right, it's easy to see what's happening. Those numbers are getting closer and closer to 2, so technically, right, if we plugged in 0, which we cannot do at this point, right, we should get 2. So that's that numerical approach, and we get the same result, right? The same limit, the same answer as with the first one. Okay, so the last way to find that limit is using algebra. Okay, so we'll take that limit, let me rewrite it, with x approaching 0, and then we have that function. So it's x on the top, x plus 1 here, minus 1. Okay, so what we'll do, we'll multiply the bottom and the top by conjugate. Right, so conjugate, let me just write a side note. All right, so conjugate is an expression which is the same as the original expression. So let's take maybe a plus b, right? So that's the original expression. Conjugate would be the same two terms, but the second term has the opposite sign. So that would be a minus b. Right, so that's so a minus b is the conjugate of a plus b. So in our case, right, where I have that x plus 1, square root of x plus 1 minus 1. So conjugate will be square root of x plus 1 plus 1. Okay, so that's the conjugate that we will use. All right, so let's do that. Okay, so we have a limit, maybe at some point, well, never mind. Limit with x approaching, sorry, not infinity. X approaches 0. Okay, and then we have the expression. So x plus 1, and then minus 1. And that 1 is under the square root. So now we're multiplying both, right, denominator and numerator by that conjugate. So that's going to be x plus 1 here, minus 1, well, plus 1, right, if we want the conjugate. And then at the bottom, same thing. So what I'm doing, I'm multiplying my expression, right, my original expression of which I'm finding the limit, by 1. Right? So technically I'm not changing anything. So x plus 1 plus 1. Okay, so what does it equal to? Maybe I don't know. Let me try to mess with it a little bit, make it a little bigger. Anyway. Yeah, so we get something like this, right? So I'm not going to write that limit, right? But the limit is in front of that expression here. So I have x, right? And I multiply it by square root of x plus 1. And then plus 1. And then the bottom is square root of x plus 1 minus 1. And I'm multiplying it by square root of x plus 1 plus 1. All right, so what do we get? So we get on the top, I have that x, and I'm distributing them, right? Distributing this to both terms in parentheses, and at the bottom, right, I'll be multiplying, I'll be foiling it basically. But when you take this term, right, and multiply it by positive 1, right, you're just getting this original term. And then when you take negative 1 and multiply it by this, you get negative, right? Negative of that. So these two will be negative, will be opposite, positive and negative, and they will cancel out. All right, so let's look at that. So we have x plus 1 plus x, and the bottom will be, right, if I'm multiplying these two, right, I'm basically squaring it, so that cancels that square root. Okay, I think we need to take a break now. Just grasp people. Okay, so when we multiply those two parentheses in the denominator, and as I said, we can FOIL it, but and it's a pretty and when you multiply two conjugates, you just get you multiply the first two terms and then these terms, right? Essentially. So out of when you multiply these two square roots, they cancel out, right? So you get x plus 1, and then negative 1 times positive 1 is negative 1. Okay, so what do we get? I can see that I shouldn't have distributed that x. Anyway, we can factor it out, right? So I factor it out. So we get x plus 1 plus 1. And then the bottom is, right, these two negative 1 and positive 1 cancel out, and you end up with x. All right, so now if we cancel those two x's, we get square root of x plus 1 plus 1. That equals to 2. Well, let me actually, hold on. Yeah. Let me write the limit. Right, so we have a limit with x approaching 0. Okay, and then actually I don't have this, right? I don't have a fraction line anymore. So I have square root of x plus 1 and then plus 1. So now we can plug in that 0. Right? So if I plug in that 0 in for x, I get square root of 1, which is 1 plus 1, so that's 2. Okay, so yeah, we confirmed that that 2 is actually the limit of that function when x approaches 0. All right, let's do a couple other examples. I want to show you an example that, well, actually maybe later. So let's start with this one. So this is example 3. And we need to find the limit again. Limit as x, let me just go back to 100%. As x approaches 2. Okay, and the function looks like this. So it's a piecewise function actually. So we have 2 functions. So f of x equals 1 if x, actually I like it bigger, as x does not equal to 2 and x equals 3 if x equals 2. Okay, so this one we'll just solve it by using graphing. Okay, so we have a coordinate system. Okay, so let me put a couple numbers. So 1, 2, 3, 4, and then we have 1, 2, and 3, and a couple negatives. All right, so the first function is y equals, or f of x equals 1, right, if x does not equal 2. So we need a hole at 2. Okay, oh, hold on. All right, so hole right there. And yeah, so this is the graph of the first function. Right, so it's this one. Right, so basically y equals 1. Right, so I have this straight line, horizontal line, at y equals 1, except for the situation when x equals 2. When x equals 2, I have 3, right? So that's my second function. That's this one. Okay, so 1, 2, 3. Okay. All right, so we're 1, 2, 3. So we're here. Okay, so this is 3 right there. This is 1. Okay, so now the question is, right, as I said, we will be solving it just by graphing. So the question is, what is the limit when x approaches, let me grab that, x approaches 2, right? So x approaches 2 from this side, x approaches 2 from this side. And remember, it doesn't matter what happens at 2, right? What matters is what happens close to 2. So when we get close to 2, right, not when we're at 2, the limit is 1, right? The value of the function is 1, right? You guys see that, right? 1, right? As I get closer and closer to that 2, nothing really changes. It only changes at 2. So I'm going to write limit of that f of x, where x approaches 2, right? F of x is 1. Okay, so that's the solution. Okay. Yeah, let me give you a couple problems for practice. And yeah, then I'll show you more examples. I want to show you examples where the limit doesn't exist. Anyway, so practice. Yeah, so so try to solve those on your own. The first one, and I'll maybe mention, after I write those problems, I'll mention what techniques we have, right? So limit with x approaches, I think it's 3. It's written in my notes in such a way that it's hard to see. Anyway, so we have x squared minus 9 in the top, x minus 3 in the bottom. Okay, so that's the first problem. The second problem, I have limit with x approaching pi, and the function is sine of 2x. Okay, problem number 3. A limit with x approaching negative 3 this time, and we have in the numerator I have x squared plus x minus 6 x plus 3, so that's problem number 3. Problem number 4, it's a limit, let me write it here, with x approaching 4, and then the top is radical x plus 5 minus 3, and the bottom is x minus 4. And the last problem, problem number 5, is it the last? Yeah. So we have a limit with x approaching 2, and I have 4x squared, sorry, 3x squared minus 4x, and the bottom is 5x cubed minus 36. Okay. Yeah, so we have a couple techniques, right? So let me just mention it briefly, right? So first technique, so technique number 1 was factoring. Well, actually, first technique, or well, whatever. First technique is factoring. So you factor the top and the bottom, and maybe something cancelled, like problem number 1. Right. So if you plug in directly that 3, you're getting 0 in the denominator. So that's undefined. You cannot have it. So you need to somehow get rid of that x minus 3 or that 0 in the denominator. And so similar situation in problem number 3. Okay, so that's the first technique. The second technique is simply just plugging in, right? So you can try, right? I don't know, maybe number 5 would work. So how should we call it? Substitute. Right? So you simply calculate the value of a function at that number, and sometimes maybe it'll work, right? Problem number 5 maybe looks like this. Okay, so that was the second technique. And the third technique was that it was that conjugate, right? So third, see, I did it again. I don't want that circle there. So conjugate. Okay, so we have those 3 techniques. Yeah, so use them, see what happens, and show work, right, when you're solving those. And here are the solutions. So the first one is 6. The second one is 0. The third one I have negative 5. Number 4 I have 1/6. And number 5 I have 1. I hope these are correct. Yeah, fix this. Okay. All right. So I want to show you a couple more examples, maybe examples where limit doesn't exist. So example number 4. Okay, so again, find the limit. The limit f of x we have a function that looks like this, absolute value of x in the top, x at the bottom, as x approaches 0. Okay, so let's try to figure out what's happening here. Alright, so this looks like a little bit like a piecewise function. So let me write it. F of x equals, so I have that absolute value of x at the top and x at the bottom. Yeah, so let's try to figure out what is happening here. So if x is bigger than 0, so I'll be plugging some numbers in for x, right? So if I plug in, say, 6, 3, right? So hold on. So for x, we're just trying to figure out what's happening, equals 6. So what do I get? Right? So I have absolute value of 6 over 6. Right? So that simply is 1. I don't know, let's try one more. So maybe for x equals 2. Alright, so I'm picking some random x's that are bigger than 0. Alright, so I get absolute value of 2 over 2, so that's 1. Okay, so seems like for x larger, greater than 0, f of x is simply 1. Alright, so that's the first case, first situation. And for x less than 0. Alright, so again, right, that's a couple of those examples. So for x equals negative 3, right? So what do we get? So we get absolute value of negative 3 divided by negative 3. That's absolute value of negative 3 is 3. So that's negative 1. Alright, so the same thing happens for every number that I pick, right? So if I pick negative 16, I get positive 16 over negative 16. So I would get the same number, right? The same answer. I would get negative 1. So f of x in this case is going to be negative 1. Okay. So yeah, let's graph it now. Let's graph it here. So what is happening? So let's say this is 1, this is 2, 1, 2, 1, 2, negative 1, negative 2. Right, so for 0, right, my function is undefined. Right, so I'm putting, so basically I'm graphing, let's say I'm graphing this one first, right? So f of x equals 1. Right, so that function applies to x's that are bigger than 0. Right, so these x's. Okay. Yeah, so let's graph it. So for 0 I have undefined. Right, so I'm making an open circle right there. Then it's supposed to be red, right? And then x is right bigger than 0. Okay, yeah, so that's the first one. And now the yellow one, what is it? Not here, this one. Right, so for x is less than 0, I get negative 1. So I'm gonna make an open circle right there. And this is the graph. Okay, so now you guys see that now if I look at that, if I try to figure out the limit, right? So the way we figure out the limit, we just get closer to our, right? We need to get closer to x, right? X is supposed to approach 0. Okay, so I'm getting closer towards 0 from the right, right? and I'm going to mark it like this. So I have a, let me write it. So we have a limit with x approaches 0 from the right. So I put a little plus there, right, above that 0. Right, so now I have f of x. Okay, so the way it would read is limit with x approaching 0 from the right, right, of that particular function, square root of, not square root of, absolute value of x over x. Okay, so when that happens, when I have that, right, I'm approaching 0 from the right, you guys see that the limit is 1. Okay, so let's make it, the limit is, let's see, make this a little closer here, and then I can write that 1. Okay, so that's going to be the red 1. Okay, so that's the limit with x approaching 0 from the right. So now the second case, and the second branch of that function is, right, this one, and the yellow one. So now I have the limit with x approaching 0 from the left. So I put a minus right there. Right, so that happens, right? So we have that f of x here, and that's going to be equal to -1. Okay, so I hope you understand what's happening, right? So what is happening is I'm I'm looking at I'm approaching that 0, right? That's what I need to do, right? That's what it says in the, right, when we were writing the problem over here. Okay, so I'm supposed to approach 0 from, well, x is approaching 0, and, well, they approach 0 from left and right. And unfortunately, here, when I approach 0 from the right, right, it's this situation here, I get 1. If I approach 0 from the left, I get -1. Right, so because, so let's write limit doesn't exist. And it's missing there, right? Doesn't exist because, and let's write it, we can fit it here. So limit with x approaching 0 from the right, f of x, does not equal the limit of the function x approaching 0 from the left. Right, so when that happens, we simply write doesn't exist, D, N, E. And we're done. All right, so that was one situation where limit doesn't exist. Let me show you another situation. Okay, so let me just write the problem rather than writing out the whole sentence. So example 5. That's it. We need to figure out this limit with x approaching 0 of a function like this, 1 over x squared. Yeah, so again, right, we could try to do it analytically, but you can see that it's not really possible. Because if I plug in that 0, I get 1 over 0, right? So something undefined. We could graph it though. So let's graph it. Okay, so let's just do it. Let's pick a couple points and right? So for 1, I get 1, right? For 2, I get 1/4, so I'm getting closer, right? For 4, I get 1/16, and then for numbers that are between 1 and 0, I get bigger numbers. So over here, let's pick a different color. Let's make it green. All right, so that's the right branch. Okay, and now if I, and obviously here, let me actually get rid of that because I want to, right, that graph, that branch, right, it's supposed to be getting closer and closer to the y-axis. Okay, so that's the right branch, and if I start plugging a negative number, I got something that's on the left side, right, of the y-axis. It's symmetrical to that one. Okay, so that's our graph. And okay, well, so let's think about it. What's happening when I'm getting closer to that 0? And the closer I get to 0, right, so this is supposed to be an arrow, right? So I'm moving this way with my x's. So what's happening with the y's, right? So if I get closer and closer to the y-axis or to 0 from the right, the y's, the value of the function, just goes up, right? Goes up to infinity. And the same thing happens from the left, right? So my x's are getting closer and closer to 0 from the left, and when that happens, y's are just going closer and closer to, well, getting bigger and bigger. Okay, so yeah, the conclusion is when that happens, right? When I have when the function values of the function go to infinity, limit doesn't exist. Okay, so that's our conclusion.